I know I'm going to start out with 5 grams. And it's e to the, I know that my k is negative 0.000428, and that's getting multiplied by the 1620. This is the question that they're actually asking me. How much is there after? Oh, that's not what I wanted. My bad. Sorry. What do I want?
10,000.
10,000 times 10,000. So then you type that into your calculator and poof, out pops an answer. Hopefully you get what I got, otherwise one of us is wrong. I get 0.069 grams. Now, common sense wise, just thinking about this problem, kind of knowing whether or not you're on the right track, if you know that every 1,620 years, half of it's gone, how many times have I chopped this thing in half? Well, let's see. Twice would have been 36, right? 3 times is about 4,800 years. So it's about 6 times that I've chopped it in half. So you'd go from like 5 grams. If you're just trying to think about this, you'd go with like 5 grams, 2.5 grams, 1.25 grams, 0.06 grams, 0.03 grams, 0.015 grams. There's once, twice, 3, 4, 5. Chop that in half. 0.0075 grams is what I would have guessed. 0.075 grams is what I would have guessed. And I came out with 0.069. And that's just knowing that the half-life occurred 6 times, because that's how many 1620s would go into 10,000 roughly. So that kind of gives me an idea of whether or not my answer makes any sense, if you were just trying to think about that. Please no crapping in here, Catherine. That's on video. For the people who are struggling to listen, I'm going to also write it. I want you to turn your diagnostics on. That means you're going to go second, 0. I want you to hit the letter D. For Olivia, that's the one that comes after C. You're going to arrow down until you see diagnostic on. And then you're going to hit enter twice. You should see the word done. Yeah. Next, we're going to make sure that you put these in your list. The X's go in list 1. The Y's go in L2. In case you didn't remember how to do that, maybe you could write this down. You want to, in order to do that, hit stat and then enter. And you can start putting things in your lists. Okay, so we've done that now, hopefully. I'm going to go into my calculator where I've done that. Here I am. So list 1, you can see I have all the stuff that were the X's. List 2, I have all the things that were the Y's. In order to do what they're asking us to do, which is a logarithmic model, you're going to go stat. And for those of you who are a little bit challenged, you can, when you watch a recording, kind of see what's going on, or just watch up there. You're going to go with, then, after that, calc.
You arrow over to calc.
Wow.
Okay.
A little more caffeine for some people than others. Right, Joe?
Wait, what was it?
Yep.
And what kind of model do we want?
Logarithmic.
Logarithmic. There's LN, which stands for logarithmic.
Oh.
LN. Yep. I know it's really confusing, so you can just look. And then you can hit enter.
No, Jeremy Reed.
And then hit it again. And oh my goodness, what don't I have that you have?
Got it. The R's.
The R's. Because I didn't go second, 0, D, which comes after C. I didn't arrow down to diagnostic on. Because I was dim. And I hit enter twice. So now I have to go stat, calc, and then I have to arrow down to my log regression. Now logistic, LN, very important. Hit enter twice. And now I see these R's.
R.
Now, when you see an R that's really close to 1 or negative 1, that means you have the strongest model. So for example, if I had an R, not R squared, if I had an R that was 0.98, and I had another one that was 0.99, which one's better? 99. Whichever one's closer to 1. It's recorded, so you can watch it again. So the closest one to 1. This is telling me that my model is super strong. So now I'm going to write this stuff down on the board. Just in case you didn't remember what we just did, here it is. We did stat, calc, LN regression, enter, enter. And what we saw at the very beginning was y equals a plus b natural log x. And then after that, what we saw is that our a was roughly 1.071, that our b was roughly 3.0095, and that our r, which is our correlation, our strength of association here, was 0.999. How many nines were there? Like 5? 6. That means super strong association. And if I write the equation of this thing, I would write down y equals 1.071 plus 3.0095 natural log x. This is my model of what's going on. If I wanted to see this on my calculator, what I would do is I would type that equation into my calculator in the y equals. So if I type in 1.071 plus 3.0095, oh my goodness, are you kidding me? 1.071, sorry, plus 3.0095
Bingo.
lnx,
Yeah.
and then I go and zoom, and since I was using statistics, I'm going to zoom. Why 9?
Zoom stat.
Zoom stat, because I have some statistics. So I look at my log growth there, and one of the things I did not do is I did not put in my stat plot on, so I'm going to turn it on now. So second y equals, turn them on. I'm going to have a scatter plot, and now I'm going to do zoom 9 so I can see both. What you can see from this model on the calculator is that the log graph that's going up to the right kind of looks like a square root graph, but it's not because we just don't see the bottom part of it yet because of what was in our table. But you'll notice that all the points that were on the graph are now being hit by my log equation. That shows you how good of a model it was, hit every single point. That's pretty impressive. Alright, so in list 1, as in the past, you put your first list. In list 2, you put your second list. When you do this time, if you were reading the directions, you would have gone stat, calc, this is a dramatic pause. Adira? Excellent. Exponential regression, because they tell you want an exponential model. And then the enter. When you do that, what you should see for your model is you should see something that says y equals ab to the x. And after you see this ab to the x thing, you should see that your a is 5.8001571 or something like that. You should see that your b is 1.094179336. And you should see that your R is 0.999986905 or something like that. And then what you want to do is when you write your model, you want to be reasonable. So when you write your model, it's always a y equals. If you don't have y equals, you don't have a model, because your model is an equation. So I'm going to go with, because there's a bunch of zeros for the a, I'm just going to go with 5.08 in the beginning. And then you're supposed to have b, which is your base.
5.0.
Oh, is it 5.8?
5.80.
Thank you, sorry. Thank you, 5.8. And then the next part's your base b, it's a number. So I'm going to, just because I don't like to make mistakes, I'm going to indicate that there's going to be multiplication with the parentheses instead of just going times. It helps me see it better. And I'm going to put in 3 decimal places. So I'm going to go with 1.0942. Because remember, I want 3 decimals after the 0 kind of thing, just to be accurate. And then don't forget your x power, because that's why it's called an exponential, because the variable is in the power. Now, if I want to find my profit in 2005, what I'm going to do is I'm going to plug in a number for the x. What number am I plugging in for the x? 15. So I have to go y equals 5.8, 1.0942 to the 15th power. Now, depending on which decimal you went to, we all might be a little bit off. Like if you dump this whole equation back here, the way I taught you a long time ago, how to put in your y equals directly from when you do the stat calc thing, you're going to have something that's more accurate than mine. And I know how to do that on my calculator, so I'll check for that. That's fine. But the answer you get out when you type this in is roughly 22.375, when I put this stuff in, 2255142. And the thing you have to be careful is if you write that as your answer, you are wrong. Because if that's your profit, you're saying it's $22.38. This is millions. So if you actually want to be like accurate, you should be moving the decimal place, right? This is saying 22 million. So you should say 22,375,225 and 51 cents. If you're going to the nearest penny. So you can write it with the word millions if you want, or you can actually write out the number if you want. Make sure you read the directions carefully. It's in millions of dollars. If you don't put the word millions, you're wrong. Or if you don't write it in millions of dollars, you're wrong.